Hello, my name is Emma, and welcome to Design Patterns in Minutes by dpatterns.com. Today, we're exploring the Iterator design pattern, a pattern that allows you to access the elements of a collection one by one without exposing its internal structure. Think about how you read a book. You don't need to know how the book is printed or bound. You just open it and start turning pages, one at a time until you reach the end. The Iterator pattern gives your code that same simplicity, a way to move through a collection of objects without needing to understand how it's organized inside. In most programs, you deal with collections all the time: lists, arrays, trees, or even databases. Each of these may store elements differently. Without an iterator, you'd have to write separate code for each data type just to loop through them. The Iterator pattern standardizes this process. It defines a common interface that allows you to move to the next element, check if there's more, and retrieve the current one, no matter what kind of collection it is. For example, let's say you're building a music player app. You might have playlists stored as arrays, linked lists, or even fetched from an API. The Iterator pattern lets you play songs one after another without caring about how they're stored. The player just says, "Give me the next song," and the iterator takes care of the details. The structure of this pattern is straightforward. You have a collection class that holds the data, and an iterator interface that defines methods like hasNext and next. Different types of iterators can be created for different traversal strategies. For example, forward, backward, or filtered iteration. This pattern also makes your code more flexible and testable. You can swap out one collection for another, or change the iteration logic without breaking the rest of the program. It also allows multiple iterators to traverse the same collection independently, just like two people reading the same book at different speeds. One of the most powerful aspects of the iterator pattern is how it supports the single responsibility principle. Your collection's job is just to store data, while the iterator handles how that data is accessed. That separation keeps your code clean and modular. In modern programming languages, iterators are everywhere. Whether you use for each, map, or for subloops, you're already using the concept behind this pattern: the ability to traverse data without exposing its internals. To summarize, the iterator pattern provides a consistent way to access elements in a collection, one at a time without revealing its inner workings. It simplifies traversal, improves flexibility, and helps you write cleaner, more maintainable code. Thank you for listening to Design Patterns in Minutes with me, Emma. For the full explanation, examples, and diagrams, visit dpatterns.com.